Okay, so the who cares lesson or sum and difference. No, it's really sum and difference rules. Okay, so first one, it's not a sum or difference, right? It's just 5x to the fourth, right? So we want to do f prime at x. So we know that's 5 times the derivative of x to the fourth, which is derivative of x to the fourth?
4x cubed.
4x cubed. 5 times 4x cubed is 20x cubed. And what we got? Y equals, so that's equal to 2 over x. Oh, wait a second, let's get rid of that radical. So what is this? Expressed in exponential form? 2/3, which is 2 over x to the 5/3. So y is equal to 2x to the negative 5/3. Right? We need to write it in the form of like c times x to the n, which we can now differentiate. So we know that y prime is 2 times, and what's the derivative of x to the negative 5/3?
Negative 7/3.
Really?
Oh, never mind. 8? Yeah, 8/3.
Let's go with negative 8/3. So that's negative 10x to the negative 8/3 over 3. But we might want to put that back into a more radical form. So radically speaking, what is it? So the negative says, oh, you got to go down there. And the root is, and the power is. Okay, so it's, take one of those. Negative 10.
Which one?
Negative, I don't know, man. Take a Kleenex. Negative 10 over 3 times the cube root of x to the 8. Yeah, so if you're sitting looking at this saying, I don't have this, then it goes up there. Hey, look who's back. Okay, y prime is negative 10 over 3 times the cube root of x to the 8, right? So we take a radical, we change it to exponential form, we write it so it's of the form x to the n. If that means it needs a negative exponent, we do that. We use the power rule, right? So the derivative is n, x to the n minus 1, and then take one of those. And then if we want, we change it back into radical. What is g of x if g prime of x is negative 6x cubed? So, all right. Let's kind of build this up, right? So we're down here, but we want to go back up here. So what power was up there? There was a 4 there, right? So we know that 4 times something, which we're not going to call x because there's x's there. So 4 times something is equal to what? Negative 6. So what's the something? Negative 6/4, which is really negative 3/2, right? So the constant that was in front was negative 3/2, right? Then it became negative 3/2 times 4x cubed, and 4 times negative 3/2 was the negative 6, and then we get the x cubed, right? So g prime of x was negative 3/2 times 4x cubed, right? The constant times the derivative. This, we know, hey, I want that to equal negative 6, right? So we'd say, well, 4 times something would give that negative 6. There we go. Is that it, though?
What's C?
So we could add, you know, like, so you put a constant on there, right? We'll get to that. Not all of us have done this first. Okay, so we'll get to that, yeah. There are other possibilities, right? 3a, is it next? Yes, use first principles. Definition of derivative, given f of x is 5x squared minus 2x plus 3, find f prime of x. So I think I said we were done with this. We're not done with this. Right, so we think back and we say, what's the first, this is called first principles, right? Definition of the derivative. F prime is the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, so we plug in, we have an f of x. So it's the limit as h approaches 0. And I still have the last page to mark, because I was at this meeting some of you know. I was at this meeting last night and it went on forever. You know, and you wrote last period of the day, so it's not like I had any time during the day to make other excuses. But I mean, usually I'm pretty good. Those of you who had me before know that usually it's same day turnaround. Okay, this case, sorry. All right, what do we got? It's okay. So we got 5x plus h squared minus 2x plus h plus 3. Okay, now put that in brackets, right? That's f of x plus h. Minus, I mean, you don't really need the bracket. I like them though, right? It just sort of says, hey, this is your f of x plus h. Now you're going to do minus, this has to be in brackets, all right? Okay, so 5x squared minus 2x plus 3, close that, all over h. And I suppose really we should kind of bracket the whole thing, right? It's the limit of that whole thing, which really is one whole thing. Okay, so you know what to do, right? Move a little bit over to the left so you've got some room. I can just square that and then multiply it by 5, right? So 5x squared plus 10hx plus 5h squared. Okay, so 5x squared plus 10hx plus 5h squared minus 2x minus 2h plus 3 minus 5x squared plus 2x minus 3 over h. Right, and then we start saying, well, handily enough, the 5x squared disappears, the minus 2x of the 3's, right? I mean, this minus 5x squared, we got a minus. So basically every non-h term disappears, right? And then we divide through by h. So I'm going to throw one more limit down. So everything gets divided by h. We got 10x plus 5h minus 2. And now h approaches 0, so what are we left with? (10x minus 2), right? Actually, that goes in the green bin. Green paper, blue pop. No, the green bin. The big green. It's like, take one of those. What, the big green bin or the Kleenex box? No, the piece of paper. Okay, so this is, that's f prime of x, right? Which is what? What is f prime of x? I mean, it's the derivative, but it's the slope of the tangent line to the curve, whatever that curve was, 5x squared minus 2x plus 3. At any given point x, you plug it out. I want to know the slope when x is 72. I put a 72 in there. I will get the slope. Okay. Oh, what's next? New page. If g of x is 5x squared, and h of x is 2x, and p of x is 3, then, okay, what's g prime of x? So it's 5 times 2x, right? We isolate the constant, it's 5 times the derivative of x squared, which is 2x, right? Which in future, you're just going to say 10x, right? And h of x. So h prime of x is equal to 2 times, what's the derivative of x? 1, which is 2. And p prime, I guess I could see not using I, but, you know, j, k. Anyways, p prime is what? Well, the derivative of a constant is 0. Right? We even proved it. Remember the big proof, like c minus c over 0. Yeah, 0. Okay. Note that f of x was 5x squared minus 2x plus 3, right? It's g of x minus hx plus p of x. And f prime of x, how does that relate to g prime of x, h prime of x, and p prime of x? So what are we going to say about f prime of x is equal to what? You might have to look a smidge up your page. The 10x, so what's 10x? What's another way to say 10x? G prime of x, right?
Would it be minus the h prime x?
Minus h prime of x. Plus p prime of x. Which was 0 though, right? But it's still there, right? I mean, because, you know, we want to relate it to this. Right? So it's just sort of, hey, take the derivative of this, subtract the derivative of this, add the derivative of this. And, oh, this whole sum and difference rules, right? Sort of, oh, you're just adding and subtracting, you know, terms in a function where you just add or subtract the individual, you know, derivatives. Which leads us to the sum and difference rules. If f and g, and you can all keep going, right? If f and g and h and I, right, are differentiable functions, then so are the sum, f plus g, and the difference, f minus g. So f plus g, now you did this notation last year, right? Or last semester, or in 30-4. It used to be a 20 subject. So f plus g prime of x, we add the two together, is simply the sum of the derivatives. And f minus g prime of x is simply the difference of the derivatives. In Leibniz, you gotta figure that out. Look that up. D by dx of f of x plus g of x is equal to d by dx of f of x, right? Derivative of f plus d by dx of g of x, and, you know, similar. So the derivative of the sum of two functions is the sum of the derivatives, and the derivative of the difference of two functions is the difference. Like, I don't know if I can squeeze difference into here. Let's try. Just. It's just big enough. Like the Peter principle. There's some principles like time expands to fill the work, right? Or work expands to fill the time. I don't know. Wow, that's big. Differentiate h of x equals 4x to the 9th minus 3x cubed minus 2. Okay, so we should do a little manipulation first, right? Like we should go through and divide everything by, so let's do this. H of x, so it's 4x to the 9th over x to the 4th minus 3x cubed over x to the 4th minus 2 over x to the 4th. Okay, they're the same, right? But now it's written as a sum or difference, right? It's like take this, subtract this, subtract this. But wait, well, we can't, you know, so we got to go further. So this is 4x to the simplified 2, 5. I'm trying to hold my thumb if I can't. Minus 3x to the
3, all right.
3 minus 4 is negative 1, right? We're just subtracting. Not well, but we are. Minus 2x to the negative 4. Now, we can find each of these individual derivatives, right? And it's time we stop playing the game of it's 4 times bracket and just go with it. Okay, so what is this? So h, that's h of x. H prime of x is equal to x to the 4 minus, oh wait, is it minus? Three x to the negative 2. Plus, minus, pick one. Plus, what number? 8x to the negative 5. Right? It's easy stuff, no fractions here, right? I mean, they're just integers. Which we can then write, because God forbid you stop at this point, right? I'm done. No, you're not. So now what we do is we factor out the lowest power of x, which is x to the negative 5. So that gives me 20. X to the negative 5 plus something gives me 4. 9. Plus 3x to the, I want to multiply that by something and end up with x to the negative 2. Negative 5 plus something gives me negative 2. And we'll keep the last one simple, so it's just 8. Which is equal to, you can't have negative exponents, so it's 20x to the 9 plus 3x cubed plus 8 over x to the 5th. Right? So you get to do that. Isn't that fun? Right, so we factor. It's more fun when they're fractional exponents, right? Then you're sitting there saying, oh, I've got a negative 7/3 is the lowest number, and I need to get, I mean, luckily the other numbers tend to work out nicely, so. Okay. So what do? We divided each term by the denominator, right? We split it out, simplified it down, so each of them was a, of the form c times x to the n. Took each derivative, and it's just the sum, right? Dropping the pretense of saying, well, it's 4 times 5x to the 4th, and just going with 20x to the 4th, plus, right, we're going to watch that, signs, plus 3x to the negative 2, plus 8x to the negative 5. Then we factor out the lowest, right? So the lowest power of x is the one that's common, giving us this, and then moving it down here, and you're done. Determined. D by d, what's determined mean? Show your work, right? You won't see it, well, there is no diploma in 31, so you're always going to see determined, right? You won't see them in a multiple choice, right? Like, whatever, it's blah, blah, blah is, and then you got 4 choices. You won't see the numerical response, because you can't show work. Okay, d by du of, oh, okay, well, so what do we get to do with this thing? Complete that sentence. Really? Oh, sorry. You could have put a comma foil. All right. You got to foil that out, right? You're going to multiply out the 2 binomial. I mean, because what's that going to give us, right? It's going to give us 4 terms. Maybe they collect to 3. I don't think they do, but, or 2 terms or whatever. But it's going to give us a number of terms where it's just something plus something minus something plus something, right? And and we know how to do that, right? Then we change anything that's radical into exponential, and everything's written as a nice positive or nice power, right? In the form something x to the n, and then we take each derivative, and we factor out. Okay. So it's d by du of, and now we multiply, right? So what do we get? 15 root u. What's that? Minus 3. Minus 10. Oh, that's nice. It is just two numbers. Plus 2 over root u. Okay, so now we want to write everything as a power. No denominators, right? So just put equals d by du. So what do we get here? Okay. Any point you disagree, let me know. No, really, I should. I'm going to put that last, but it doesn't matter. Okay, so keep going. Well, so let's actually take the derivative. So what's that first one going to be? Write it as a fraction. No decimals, right? No decimals. Nothing there. This. Okay, so it's a half times 15, which is 15 halves, u to the negative 1/2, right? I'll say this with confidence. At some point you can say, you're wrong on something. Okay, what's the derivative of minus 13? 0, so okay, plus 0, minus 0, whatever, I'm not going to write it. And then negative 1/2 times 2, I mean, really I should have just written that as negative. You know, maybe throw that in brackets just so we can see, okay, those are going to go away. So, okay, let's clean this up. We're done, not even close. So now we have to factor out what? What are we taking out? You have two choices. Bless you. You could say u to the half, or you could say u to the negative 3/2. So which one's lower? Negative 3/2, right? So we're going to factor out u to the negative 3/2. Okay, u to the negative 3/2 times u to the something will give me u to the half. Squared, right? 4/2. Right? So you're going to say negative 3/2 plus positive 4/2 will give me 1/2, but 4/2 is 2, so 15 u squared.
Should be 15 u the negative half.
You can't have any negatives inside the brackets. No negative exponents, sorry.
Right, but like earlier,
Oh.
when you maintain the derivative of 15 u to the half, and you just divide it by 2. Like, right, you didn't carry it down, like, here's 15 u, 15 divided by 2u to the negative half. So
you keep splitting it.
That! Oh, well, it changes, not everything, but changes something. Better? Ah, see? That's why you guys are here, so we have a decent set of videos in the end. Right? Seriously. Maybe you'll learn something along the way. That'd just be a bonus, right? Like, you know.
Wasn't there a mistake before?
Oh, who knows? Is there another
I'm pretty
mistake?
sure it's supposed to be just 1/2, not even the negative 1/2.
Oh, so the mistake was in the first.
Jesus, man.
1/2, so 1/2, and then I subtract 1. 1/2 minus 1 is negative 1/2. All right, so we're good now, right? I don't know. I think we're going to have to graph this and then see if it really does look like the tangent line or something. All right, so I still take out the negative 3/2. But now this is a positive 1. Okay. Okay, so we're almost there. You know what? Actually, let's do this. So let's take out the half as well, right? So I want to get the half out of there. So we'll take u to the negative 3/2 over 2, and then we're left with 15 u, and that should be, right, and then the 2's, so minus u to the negative. So that's better. Okay, so now we have our numerator, 15u minus 2 over 2 u to the 3/2. Or in radical form, 15u minus 2 over 2 times the square root of u cubed. I think that's right. Determine the equation of the line tangent to f of x equals x squared minus 3x at x equals 2. What? Go back. Back to the. I'll leave that. If you're watching at home, you can skip ahead 30 seconds.
Really, it does? So now I could have won the car.
You're done when it's in radical, back into radical form. When you have only positive powers up top, right? No negatives, so no radicals, right? And radicals are on the bottom usually. Usually.
Well, so it's like the opposite now. You want your radicals.
Now you want your radicals. I know it. It's like, really? We spent all this time rationalizing, you know? Okay. Determine the equation of the line tangent to blah at x equals 2. Wow, this could be like a test question. Only we can work it out a little bit easier now, right? So, what do you need to get the equation of a line? Slope, point. Okay, how do we get the slope? We'll say m sub tan for the slope of the tangent line, right? Slope of the tangent line. Not to be confused with the tangent function. So the slope of the tangent line is equal to f prime of x, which is equal to, see now you just state it, you don't have to do all the x plus h stuff, right? So what's the slope? 2x minus 3, right? See? A lot easier using the power and the sum and the difference. Okay, okay. Yesterday it was like f of x plus h minus f of x, or hopefully it was. Okay, and we want it at x equals 2, right? So when x equals 2, so the slope of the tangent line at the point x equals 2 for that function is 1, right? So we plug in a 2, right? F prime of 2. What is the slope at 2? Okay, it's 2 times 2 minus 3, which is 4 minus 3, which is 1. And what's the point? I asked myself that. So the point on the curve, right, is 2, negative 2. So we need a line with a slope of 1 going through 2, negative 2. So use your favorite method for getting the equation of a line, which generally we want in the form ax plus by plus c equals 0, where a, b, and c are integers. My God, it said on the test, a, b, and c are integers. Here's the news, 1/3, not an integer.
You did that? Yeah.
Right? So, you go, I just lost a half a mark.
Like an idiot. You don't want to x plus y plus h. multiply everything by 3.
That's a chunk.
You're so smart. You're reading your words. I just know that you were great. I just know Excel is supposed to be like.
Okay, so you got a few choices, right?
I'm so.
You can plug. So we know X and Y and M, right?
Yeah, you know that one.
You got an X, you got a Y, you got an M. You could plug them into Y equals MX plus B, get B, write the equation in that form, then go to general form. You could plug it into Y minus Y1 over X minus X1 equals M. Ta-da. And you can plug it into Y minus Y1 equals M, X minus X1, right? Your choice. I like this one, I don't know. Especially when the slope is just a number. So Y plus 2 is equal to 1 times X minus 2. So X minus Y minus 4 is equal to 0. Right? Positive X. Oh, by the way, the AX plus BY plus C equals 0. A, B, and C are integers, and A is greater than 0. So minus Y.
Isn't the X the 2 and the Y is the 2?
Yeah, but you're subtracting.
Oh,
So it's Y minus negative 2, which I just wrote as Y plus 2, is equal to M. Okay, so here, I mean, I don't know, so, right, so Y is equal to 1, oh, sorry, not 1. So now it's negative 2 is equal to 1 times 2 plus B. Negative 2 is equal to 2 plus B. B is negative 4. We got Y is equal to X minus 4, or X minus Y minus 4 equals 0. So that's if you like slope-intercept, right? And if you like this, it's Y plus 2 over X minus 2 is equal to 1. So Y plus 2. So if you have a fractional slope, then you just kind of cross-multiply, right? If you have this and the slope is fractional, you're eventually going to have to multiply through by the denominator to get rid of it. Same thing there. So yeah, you know, it's just...
Just rewrite it.
Nobody's confused.
Okay, so you have at least 3 methods to choose from. Pick whatever you like. Okay, doesn't matter. Oh, here's a graph. What is the graph of? Why is this graph just sitting here?
Next question.
Oh, well, here it is again. I don't know. At x equals 2. So, okay, what was the... Arrows. Okay, put arrows on your lines when you're graphing. They're telling you this since grade 10. Put arrows on your lines. Okay, determine the equation of both lines, which implies there are 2 of them, that pass through 1, negative 11, and is, I believe yours says R, because I changed it, because I thought R sounded better. R, yeah. And it's not even Talk Like a Pirate Day, which is September, who knows? Yeah, come on. International Talk Like a Pirate Day? September 19th, right? What's Towel Day? No, it's May 25th. Birthday. You don't know Towel Day? This year is 2 days before grad. We can actually celebrate it. So
we like we're all towels on it.
you bring a towel? In honor of Douglas Adams. It's, well, he died like 2 weeks before it or something. So then, just 2 weeks after, to honor his memory, they created Towel Day. Is it? There you go. Celebrate. So, we have a point. We have lines which are tangent to the curve that go through this point. So somewhere, I mean, it's not a line like this, obviously. It's a line like this. And at some point on here, this line is tangent to the curve. Okay? And we don't know what those points are. I mean, we can graph it and maybe come up with some values, but or something close, but we're just sort of going to sketch in a line that kind of looks tangent to the curve. So there's one line, and then another line that's going to go. No, I didn't. Something like that. Only somewhere it actually touches, right? Just not easy. Okay, so one more time. Determine the equations of both lines. There are both lines that pass through this point. What do we need to get the equation of a line? Point and a slope. And are tangent to this curve, which is this curve we've already used, right? X squared minus 3x. Okay, so we need the slope. What do we know about the slope of the tangent line? Yeah. So the slope of the tangent is the derivative of the function, which is 2x minus 3, right? But what else do we know? Well, we know that the slope of this line passing through this point is, so somewhere there's a point on this graph, right? And it has coordinates x and what? F of x, be more specific. It has coordinates x, y, but
X squared minus 3x.
yeah. So there's a point on this curve at x, comma, y, but not y, f of x, but not f of x squared minus 3x, right? Every point on this curve is x squared minus 3x. It's some general point, which we want to find out specifically, right? Like, what is that point? Right? What's the point? Again, I ask myself, what's the point? Well, what's a way to express the slope of this line? Slope is rise over run, right? Which is y2 minus y1 over x2 minus x1, which is this minus this over this minus this, right? So where's this going? So the slope of the tangent line, well, it can be expressed in other. Let's write that in. I don't want it subscripted.
You do it wrong, Rebecca.
Okay, so another way to do slope is to take rise over run, right? y2 minus y1 over x2 minus x1. Well, what points are we going to use? You should see your test mark. We're going to use this point here, right? Later tonight, after I get the mark. So it's y2 x squared minus 3x minus negative 11, which is plus 11, over x minus 1. Well, if they're both the slope of the tangent line, then what can we say about them? Like, the slope of the tan is 2x minus 3, but the slope of the tan is also x squared minus 3x plus 11 over x minus 1, then they must be equal to each other. So we can set two x minus 3 equal to right? So we have two different ways of expressing the slope of the tangent. One is the first derivative, which is 2x minus 3. The other is, right, remember we're looking for the slope of a specific line, the one that goes through 1, negative 11. So we just pick a general point on here, and really we just want to find the x value, right? Like, where is that point? Okay, so we set them equal to each other, and now we cross multiply and then we solve. So we do a little algebra, right? So 2x minus 3 times x minus 1. Okay, so what do we get? 2x squared minus what, 5? Okay, we keep going, so let's move everything over to the left. And let's hope for everybody's sake that this factors, because otherwise you get, and then you use the quadratic formula, but it does factor, right? So we don't have to. All right, what is that? X minus 4. So x is 4. X is negative 2. Okay, are we done? Was that it? I don't know, it was something about finding the equation of the lines, both lines, right? Yeah, not good enough. Besides, we still have time. It's not a 30-1 class. We don't have to go till 2, but we do have to go till. Yeah. All right, so we want to find the equation of the line. We know the slope of the line, right? We have an expression for the slope of the line. Well, I have two expressions for the slope of the line, right? So what do I want to find? Well, the slope of the line when x is equal to 4. It actually kind of looks like 4. We say 4, yeah, 4. And negative 2. That's close. I never actually touched. So when you want to find the slope of the line at 4, you can plug a 4 into here or a 4 into here. Any particular choice? Do you like put a 4 into this one?
Yeah.
Or yeah, I think it's right. Like, really, is there a choice? Not really much of one, right? Yeah, there's a choice, but okay. So let's close this off. So say when x equals 4, the slope of the tangent is 2x minus 3 is 2 times 4 minus 3 is 5. Okay, you got the slope of the line. We need a point on the line. So should we use this point, 4, and whatever that works out to? Or should we use the point 1, negative 11? So 4 and whatever that works out to, or the point that really just sitting there, yeah. Let's just use the point that's there, right? I mean, what's the point using this? Not much. So use your favorite method. Line's going to be in general form, ax plus by plus c. A, b, and c are integers. 1/3, not an integer. And a is greater than 0. So 5x minus y minus 16 is equal to 0. And I guess we can do this down here. Oh, so let's use a different one. What point am I going to use? No, let's not use that point. Okay, so again, let's use the point 1, negative 11, because really, do you want to be calculating the coordinates? Like, why bother? So what do we got? Negative 11 is equal to negative 7 times 1 plus b. So b is negative 4. So we get y is equal to negative 7x minus 4. So we get 7x plus y plus 4 is equal to 0. Okay, let me just slide that a bit. So I would like to visualize. I want to see this. So I'm going to go into decimals. We'll just graph all three, right? We'll graph x squared minus 3x, and we'll graph this, and we'll graph that, and we'll see if they look like they're tangent lines at the point 4, whatever that point happens to be, and 2, whatever that point happens to be. Because they should, I probably have no idea how I'm going to do this, but I can't. Okay. Well, let me know when you copied everything down. Everybody good? Yeah, arms across. Okay, so what was it? Y equals. So that was our graph. What was the other one? We got 5x minus y. And we had 7x. Hey, that's pretty good. So, really? So what did we say it was like at 4? And at -2, let's drag that down a bit. So there we go. And point 1, -11. Tangent line. Slopes. Points. Graphs. Oh, now I gotta hit the done. I have no idea where done is.